Hello there, we would like to share a story about how to protect what truly matters, your life, your loved ones, and your cherished possessions. Today we are talking about electrical fires, a sneaky threat that's spreading across the globe. Despite our best efforts, the statistics are gloomy. Lives lost, fortunes burned, and pushed us to seek better ways to prevent these electrical disasters. Unfortunately, the share of fires caused by faulty wiring and appliances keeps growing. In Russia alone, these types of fires have skyrocketed over the past decade. There are similar statistics in different countries around the world. For decades, our electrical panels have relied on trusty miniature circuit breakers or MCBs and residual circuit breakers or RCDs. You would think we would prefer these guarantees on electrical systems, leaving no room for trouble, but alas, the statistics tell us a different story. Enter the villain of our story, arc fault. Formally defined, an arc fault or sparking is the formation of an electric discharge between conductions. This phenomenon is accompanied by intense light and heat, leading to cable insulation destruction and potential ignition. The good news, there is a superhero in town, the arc fault detection device, or AFDD. The nifty gadget is already mandatory in the United States, Canada, Germany, Austria, Slovakia, New Zealand, the United Kingdom, and Russia. Different rules, the same mission, to put out electrical fires before they even start. The new edition of EAC 6036442 is worth mentioning. It was approved on November 22, 2024. The updated standard requires arc fault protection by any means. The standard also states that the use of AFDD is sufficient protection against arcing. We're going to respond with AFDD TUMOV in bright red. But wait, you might ask, why do we need AFDDs if we already have MCBs and RCDs? Great question. Here is the deal. Traditional protection can't always spot arc fault caused by loose connections, old insulations, or damaged cables. No overcurrent or current imbalances, no cause for an arc fault. AFDDs are the third step in the evolution of electrical protection, joining forces with their older siblings, MCBs and RCDs, to create the unbeatable trio of safety. Let's see AFDD in action. We've set up a demo stand with all three heroes, a circuit breaker, RCD, and our star AFDD. We simulate a dangerous serial arc fault, mimicking a weak connection in a circuit or damaged cable. The first experiment is carried out on a coal copper generator. The case is fully described in the standard. Slowly make a micro gap in our circuit. Guess what? Our hero cuts the power faster than you can say fire extinguisher. Meanwhile, the other two devices, crickets. Let's go back to the current state of affairs and take AFDD out of the loop. Slowly make a micro gap in our current again. An arc fault leads straight to fire. Neither the MCB nor the RCD, though it's necessary to trip. The curious viewer will ask where the coal copper generator is located in the electrical panel. No doubt, the operation of AFDD in the real-world environment needs to be demonstrated. Now we have a fragment of cable with time-damaged insulation. The insulation can also be mechanically damaged. As a result, the insulation loses its dielectric properties and an arc fault becomes possible. All possible causes for an arc fault are shown in this picture. Any of these, alone or in combination, can cause a fire. Once again, all our rescuers are monitoring the situation. Press the red start button. A little bit of smoke and our superhero is back on the top of his game. What happens when our hero goes on vacancy? Press the red button again. Oh, let's take our finger off the red button before we get burned. The best part? You can have this superhero in your electrical panel right now. So go ahead, give yourself and your loved ones the gift of peace and mind. After all, when it comes to safety, it's better to be protected than sorry. Stay safe and remember, electricity may be amazing, but it's no match for a well-protected home. Some technical details. The AFDD TUMOV fully complies with EAC 62606 standard. Arson detection is provided by a multi-factor, multi-stage algorithm. 35 mm DIN rate mounted. Trip cause LED always on. A single device with a rated current of 63 amps is sufficient to protect an apartment, office, or house up to 150 square meters. Special bonus. Special test unit is included in the AFDD TUMOV kit. There is a surest way to ensure that your circuit is protected from dangerous arc faults. Simply plug this unit into any circuit on your property and AFDD TUMOV should detect the simulated arc fault and trip. No real arc failure. Everything is virtual and totally safe. The test unit will not cause a short current. If it did, the MCB would have been tripped. AFDD is tripped by special pulses generated by the test unit. Let's repeat our experience with the circuit outside the protected circuit, e.g. in a neighbor's flat. Nothing happens. All the circuit breakers continue to operate. The AFDD will not be tripped by external disturbance. Install the AFDD TUMOV in your distribution board. Prevent a fire, save lives, protect your property.